So we just learned that the plates are moving. That means the crust that we stand on every day is moving due to the theory of continental drift. But when I go outside and I'm standing outside and I look down, I do not see the ground moving, like I'm standing on a skateboard or riding on a boat. So how do scientists know that the plates are actually moving? We can't see it. So there's got to be really good evidence to support this theory of continental drift. That first item of support, that first piece of evidence, is the fact that it looks as if the land masses of our continents could slide back together and fit together like one giant puzzle into one big landmass. Scientists have dubbed that landmass Pangea. If you take a look at my map here, you'll see exactly what I'm referring to. It looks as if South America can slide right up into Africa and snap into place. Australia could swing right up into here and pop up into the Alaskan area. It also looks as if this part of North America could fit around this part of Africa. That is our first piece of evidence, but it's a pretty weak piece of evidence because that could just be a coincidence based on ocean currents shaping the coastlines. So we've got to do a little better than that. Imagine standing out at your bus stop, waiting for the bus. Take a moment to visualize what type of wild animals you would see while you're waiting for the bus. Maybe a squirrel, a rabbit, a deer. You might even notice raccoons or possums that have unfortunately been killed on the roadside. Those are all native animals to this area. They've always lived here and they always will, due to the climate of this area. Now imagine you're waiting for the bus stop and walking down the street is a giraffe. Now that's an Instagram moment because giraffes are not native to this area. How about if a hippo was walking around your neighborhood? Or a lion? Where do we find those types of animals? Where do they normally live? Africa. Now, Africa, we know, has a much different climate than our climate here in North America. And that has to do with the location. Here's where we would find our little animals, right in here. And those African animals would be way over here. Very different climates. However, back to the evidence. Scientists have found fossils. Now that's not a big deal. I could go outside right now and find a fossil. Not a problem. The interesting thing is that scientists found fossils of the same plants and animals here and here. Also here and here. And even crazier, here and here. How is that possible with their very different climates? Well, that's a pretty good piece of evidence that at one point in time, those climates were the same. And in order for that to be the case, they had to be in the same area, which means that those continents were indeed together at one point. So what does that mean? It means they have moved. And if they moved, that is really strong evidence to support continental drift. Another key piece of evidence is rocks and minerals that have formed. It takes another set of specific conditions to form rocks and minerals. And once again, scientists have found the same types of rocks and minerals on the coastlines. Okay? That's really good evidence. The last piece of excellent evidence, earthquakes. What is an earthquake? It's when the earth is moving. What's causing the earth to move? The plates are moving. All of that energy that's built up from those big, huge plates trying to slide by each other is finally released in the form of an earthquake wave. That's pretty strong evidence as well. I think we've proven that the theory of continental drift is accepted due to these really strong pieces of evidence. Tomorrow, we'll discuss why the plates are moving. What's making them move? It's not little elves riding around in the mantle, trust me.